All right, this is going on page 42 when we are done. So we're going to apply the synthetic division today, like one of the reasons we actually need to do it. But before we do this, we're going to do a little warm-up. We'll do it together. It says, consider this polynomial function. So the first thing we're going to do is divide it by x plus 4. So is that something I can use synthetic division for? Yes. So on the outside goes what? Negative 4. Okay, and then in here it's going to go 1, 1, negative 4, 41. Right. Put my little remainder thing. So then bring this down. This is 1, negative 4, negative 3, 12, 8, negative 32, which leaves me with 9. Okay? We agree with that? All right, so then I have 3 of these. That means it's a quadratic. So x squared minus 3x plus 8 plus 9 over x plus 4. Do we all agree with that? All right. So now we are going to use that same function, and this time we are going to evaluate f of negative 4. So we're going to substitute that in. F of negative 4 equals negative 4 cubed plus negative 4 squared minus 4 times negative 4 plus 41. Okay? Yes. All right, so negative 4 cubed, is that going to be positive or negative? Negative. And what's the number? 64. Negative 64. Then negative 4 squared is a positive 16. Negative 4 times negative 4 is another positive 16, and then plus 41. Okay, so remember when you're combining these things, think smarter, not harder. Do you know what 16 and 16 is? 32. And 32 and a negative 64 is going to give you what? Negative 32. Plus 41 means f of negative 4 equals what? 9. Okay. Hey, sure did. All right, let's do number 2, and then we'll come back and talk about that. On number 2, it says consider this polynomial function. So we are going to divide by x minus 9. So what goes on the outside? 9. And then my numbers in here are 7. Then what? Negative 63. Then what? 0. Yeah. And then 9. And then negative 80. Be really careful with those zeros. So then bring the 7 down. It's going to give me 63. So this is 0, 0, 0, 0, 9, 81, and 1. So that gives me, this is 4 terms, right? Now, had you left out that 0 up here, you would have still gotten, this would have been 9 and this would have been 1, but you'd only had 1 0 here, which would have implied that it would have been a quadratic instead of a cubic. So this gives me 7x cubed. I do not have an x squared term. I do not have an x term, but I do have a constant, and then I have to add my remainder. Oh. All right. That's your 5 minutes, Fernando. Awesome. Thank you. All right. So now we're going to find f of 9. And so f of 9 is going to equal 7 times 9 to the 4th minus 63 times 9 cubed plus 9x minus 80. Now, if I wanted to spend the time and go through the agony, I would have you multiply all this out. What, did I do something wrong? Oh, dang it. It is 9x, but it would be nice if I actually substituted it in, right? 9 times 9, I think I got 9 anymore, minus 80. Okay, thank you. I'd have you actually multiply it all out, but I'm going to show you a, think smarter, not harder way for things like this. All right? So when 63, is 7 times 9, right? So this is really 7 times 9 4 times. You agree with that? So I'm going to take one of those 4 9s, and I'm going to multiply it by 7 to get me 63. That still leaves me with 9 to the 3rd power minus 63 times 9 to the 3rd power. Wow. Plus 81 minus 80. Did I just blow your mind there? But I guarantee you, if I had just told y'all to evaluate f of 9, y'all would have all multiplied it all out, right? You'd have had work all over the place. You'd have been carrying and borrowing and I don't even know what, okay? Some stuff that doesn't even make sense just so you have work all over your paper. Think about it, but you, guys, you can't do stuff like this. You won't recognize it if you're not used to actually multiplying the numbers on your own. Does that make sense to you? It's not about doing it in your head. It's about thinking through the numbers and having some number sense. So yeah, these two things just completely cancel each other out. And so it does give me f of 9 equals 1. Now, I'm going to show you one other way to kind of do that same thing, just because I don't know that all of you would be comfortable leaving the exponents or what. So you can do it. There's another way to kind of look at that. So I'm going to rewrite this. 7 times 9 to the 4th minus 63 times 9 cubed plus 9 times 9 minus 80. Okay. So instead of worrying about leaving exponents, I'm still going to do this whole 9 times 7 is 63 because I see that right there, right? So it's going to give me 63. Well, I still have 3 9s. Well, 9 times 9 is 81, and then I'm going to leave the 9. So then I can do minus. Well, I already have the 63. I can take 2 of those 9s and make it 81, and then I still have a 9 left over. So they still look the same. And it's not really that, you're still not multiplying crazy big numbers, but you're just multiplying what you need at that point. Okay? Does that make sense? Start thinking that way, and I promise you, all this stuff gets easier. The stuff that you get bogged down on most of the time is not the pre-cal concepts. It's all the computation and the algebra and stuff. All right, so now let's go back and look at these, why we just did what we did. Jenny said something at the beginning that she noticed. What do you notice here? Yeah, when I've evaluated this, it's the same as this remainder here, right? So what's happening is this. This is x plus 4, so you know how I was having you write down x equals negative 4, because I wanted to make sure we understood that, right? So when you do that, you are evaluating it at x equals negative 4. If your remainder is 0, then it's a factor. Well, guess what? If it's a factor, then that factor is supposed to zero out with that number, right? That's why it's working that way. So this is another way to evaluate. Like this one wasn't so bad. But had I not shown you this, and even though I showed it to you, not all of you are going to recognize to do stuff like that, you know, the next time you do it. Y'all would have been multiplying like crazy. Was this difficult at all? No, look at all those zeros. Zeros are beautiful. We love zeros, right? And so if you know how to evaluate, you can evaluate any polynomial like this, okay? If you remember how to do synthetic division and evaluate. So if you want to evaluate a number in a polynomial, it's just the remainder when you do synthetic division, okay? Does that make sense? Easy enough? All right, good deal. So let's see, the remainder theorem. If a polynomial function f of x is divided by x minus c, then the remainder is f of c. Sorry, a little brain fart there. I felt like I was writing it wrong. So x minus c, then the remainder is f of c. You're basically evaluating it at that number. So using synthetic division to evaluate a function is called synthetic substitution. Okay, synthetic substitution. All right, easy enough? Okay. Okay, so let's make sure we understand what to do with these signs here so that we don't mess all this stuff up by, able to do the process but getting the wrong number in there or something. So it says use the remainder theorem, or which is synthetic substitution, to evaluate f of x at c. So they're telling me c equals negative 3. If I want to evaluate f of x at c, that means that my x is going to equal negative 3, which means the factor is x plus 3. Okay, does that make sense? I want you to, it's f of negative 3. I want you to make this connection because when you just straight up are doing synthetic division and you have a factor, we would use negative 3 on the outside. Not because there's some magic of changing signs, but because x equals negative 3. Since we're already given that in that form, that is the number that goes outside. Does that make sense to you?
C is the number that we use right now.
Yep, that's it. So this is negative 3. Then I just do synthetic division. So this is 1, 8, 12, negative 7, and negative 14. And I think you would agree that synthetic division is pretty easy. It's just a matter of, if you haven't done it in a while, remembering how to set it up and what the process is. So you can go ahead and run through this. 1, -3. I was doing it quietly so Michael wouldn't yell at me. All right, so we get -20 there. So then your answer is f of -3 equals -20. Isn't that way better than actually substituting -3 into this mess? Look how many, I mean, it's not like taking 3 to the 4th power is that bad, but when you got a negative, there's so many places to make a sign error and just, stuff that we're all capable of. Okay, I know. All right, we good? All right, flip it over. Yes, exactly, so that you could see that it was the same. Yeah. All right, so let's do number 4 together, and we're not going to do all these, but so C is -2, so -2 goes out here, right? And then 2, 4, then what? 0, and then 2, and then -1. So, did you get f of -2 equals -5? All right, good deal. All right, now you do number 5 all on your own. If you leave out this 0, then you're not going to get the right answer for sure. So make sure.
Oh, 357 times 7.
I don't want to do it.
Do it anyway. Oh, sorry.
So they're 35.
So we got so far? Yes, very good. That's what I would do. I would do 3 times 7 is 20. So 21, so it's 2100. 5 times 7 is 35, so it's 350. 7 times 7 is 49. And you add them all up. You get 24.99, right? Which means it's 24.98. Which means f of 7 equals 24.98. Okay. What questions do we have? You got to subtract the 1. Yeah, you were right about your numbers. Okay, I don't think we need to do number 6 because it's really just doing synthetic division. But we are going to do 7 and 8 so we can talk about how to answer these questions properly. So number 7 says, the number of tickets sold during the Oakdale High School football season can be modeled by this equation, where X is the number of games played. Use the remainder theorem to find the number of tickets sold during the 7th game of the season. All right, so what does X equal? Yes, number of games, which is 7, right? So if I want to substitute 7 in. So you could substitute it in, but yuck, right? So instead, we're going to do synthetic substitution. This gives me 1, -14, 45, and 68. Okay. Go ahead and do your synthetic division. What am I doing? I am doing that wrong. I brought a 7 down. Oh my goodness, I'm making stuff up. Okay. Okay, so did we get our remainder as 40? So what does that mean in the context of this?
Number of tickets sold.
Number of tickets sold when?
7 games. With 7 games. On the 7th game.
On the 7th game?
With 7 games. When the game is 7 and they sold 40 tickets.
During the 7th game. Good, because it says right here. No, you said on the 7th game or for the 7th game. So use it to find the number of tickets sold during the 7th game of the season. So we can say 40 tickets were sold.
On the 7th.
No, during the 7th game. What is the difference? Does this seem like a reasonable answer?
Yeah.
Yeah?
Not really. I mean, there's schools like ours that got no school spirit.
Okay, but does this mean that this is how many tickets were sold for the game?
No.
No, because it says during the game. So like while the game is going on. So that wording is important. You know, saying on the game or for the game, that's different than during the game, right? So that's context matters. All right, questions? All right, the number 8. The distance in feet that a person travels on a snowboard is modeled by this equation, where t is the time in seconds. Use the remainder theorem to find the distance traveled after 1 minute. All right, so what is t going to be here? Is that, yes, it's a decimal. 60, because it says seconds and we have 1 minute, right? So t is the time in seconds. Those are important words to look at too. So 60 goes on the outside. And then we have 0.6, and then 10, and then what? 0. You do have to have a 0 for the constant term, okay? Let's put my little bracket here. Now, multiplying by a decimal is not that big of a deal. 6 times 6 is 36, so 6 times 60 is 360. 6 times 60 is 360. That 0.6 means I just move it over once, right? 36. So this is 0.6, and then this is 36. Then that means this is 46, right? Oh, God. All right.
2,400 plus 60 times 2.
Good, that's right. So 6 times 4 is 24, and you add 2 zeros, so 2,400. And then 6 times 6 is 36, so this is 360. So that means that this is 2760, so this is 2760. Okay.
You get one person right, don't know how to add.
So this 2760, what is this? Feet. The amount of feet a person travels on a snowboard, right? So a person travels, and you can write this in your own words. I don't always word them the best way, but a person travels on a snowboard. No. 2760 feet in 1 minute.
That's a long, amount of feet.
It is. But it's 1 minute's a long time, though, really. If you think about it, if you're going pretty fast. You can figure out how many miles per hour that is.
So like a football field is 300 feet. So then that's like 9 football fields that you just went in a minute.
In a minute, but you're just going shh down the, yeah.
Yeah, because football field is 300 feet long. So
Look at him doing all that math. It's so impressive. All right, do y'all have any questions? All right.